Okay. So, Chris, thank you. And, it's up to you now.
All right. Okay. Pressure's on. Well, it's nice to meet you all. My name is Chris Bendix. I'm a project developer with Mercy Housing Northwest. And I'll get into it. I have a brief presentation that I'll go through here in a few minutes. So my background is just for your sake in this group. My background is in city planning. That's where I started. That's what my training is in formally. And then after finishing graduate school at the University of North Carolina, moved back to Seattle, which is where I'm from, and picked up at Mercy Housing Northwest, which is where I've been for almost 5 years. And I'm managing this project here in Lake Oswego at the former Marylhurst campus, and also another project that we have going over in Vancouver. So.
And you're located in Seattle too, right?
Correct. Yeah, I'm based in Seattle. Our offices are in Seattle.
Good. Okay.
All right. So can you all see my screen?
Yep.
Okay. All right. So to start a brief introduction into who we are as an organization. So Mercy Housing Northwest is a 30-plus-year-old nonprofit affordable housing developer and operator. We own and operate over 50 properties in Washington, Idaho, and soon in Oregon, with over 6,000 residents across the states that who we call neighbors. Most of our properties are located along the I-5 corridor, more or less, between Olympia and Bellingham. One of the things that we always focus on is building resilient communities. That means through resident services. And that also means through the buildings that we build and the systems that we put in them. Resilience here in terms of both social resilience and environmental sustainability. So that's really what we're going to focus on today with this brief presentation that I have for you all. The project team on the Marylhurst Commons project that we're working on, we are partnering with the Sisters of the Holy Names who own the campus and will continue to own the campus. We will be ground leasing from them, so they will stay with us for the long run. The architect on the project is Carlton Park Architecture based in Portland. They have extensive experience working on both affordable housing properties like this, as well as sustainability projects and other civic projects in the Portland metro area. Walsh Construction Company is our general contractor, and Brian, our sustainability consultant. So the project goals for this property is to provide long-term affordable housing for families. That's our mission as an organization, and that is what we do primarily, as well as providing services for residents through on-site services and programs. And that is in a property like this, which has a focus on families, that really means making sure we're focusing on out of school time, success in school, and the connection between home and school and education for our residents who are under 18. In this case, because of the unique setting being on the former campus, we wanted to preserve space on campus as we could. That was a stated goal. We wanted to improve accessibility at the property. That was another strong goal, not only for us as well as for sisters. We wanted to have a design that blended in with campus. We wanted something that was energy efficient and sustainable, which is what we're going to focus on today. And then we wanted long-term, stable community and a comfortable place to live. That's what we strive for in all of our properties. So for some further context, this is a map of former university. See here the Mary's Woods retirement community here, and then all the former. We're redeveloping a small portion way out on the eastern edge, moving to old dormitory buildings that were built in the 1960s, and then rebuilding a similar footprint.
So Chris, when you turn your head, you're cutting out a little bit for me. Is that true of other people?
Yes.
Okay, sorry.
Yeah.
I'll try to
Yeah,
keep myself
thanks.
facing the screen. Yeah, sorry.
Yeah.
So as I was saying, the far eastern portion of the property is where we're going to be building our project in something resembling the same footprint of the buildings that were already there. I'll flip through a couple of images here, architectural renderings of the property. It's a 3- and 4-story building with 100 units of housing, a mix of 1, 2, and 3-bedroom apartments in a U shape with the central courtyard that faces west and opens out towards the rest of the open space on campus. This is a close-up of the courtyard space, which is a residential amenity. There's going to be a playground and community garden and other spaces to sit and relax. So speaking more specifically about the sustainability goals for the property, the first thing that we established was we wanted the project to be 100% electric and not rely on fossil fuels at all. That was a fairly easy goal to achieve. That one was a fairly low-hanging fruit. The second goal was to pursue a passive house certification. This is a pretty rigorous certification. One of the reasons that this is more rigorous than some of the other certifications, for example, things like net zero or LEED, those two programs let you offset or purchase offsets. You know, if you get as close to net zero as you can, and then you purchase offsets to produce offsite net zero energy somewhere else, the passive house program does not allow for that. It has to be performance-based on site. So what that means is very tight building envelope. So very lots of tape essentially on the exterior of the building to keep the drafts out and make the building very airtight. It means that we're doing heat pump based hot water heating, not a conventional forced electric resistance tank type hot water heater. It means balanced ventilation with heat recovery, which I'll talk about a little bit in a moment. And I already touched on the on-site performance focus as well. So I'm going to dive into just a couple of the two big systems that we're talking about. And I want to sort of put an overarching goal on this, which is that the goal of this is to make the building as close to net zero as we can. And that means both these big systems as well as on-site energy production through solar photovoltaic on the roof. And another big goal that we have is making the building as resilient as we can for more extreme weather. And that's where the balanced ventilation with heat recovery comes in. So this system, which I suspect you may have heard of, relies on a constant supply of both exhaust air coming out of the building and pulling fresh air into the building at the same volume. And what we're doing in this property is centralizing this. So we'll have 9 rooftop mounted ventilation units. And then from there, we'll be pulling exhaust air out of every unit, as well as the common areas, from the bathrooms and the kitchens. And then that will go up to these rooftop units, where those units will be pulling in fresh air from outside, filtering it through a MERV 13 filter, which is the minimum required to eliminate particles associated with wildfire smoke. Then that fresh air will be distributed back down through the building to every living space and every bedroom in every unit. So the effect is we have a very tight building envelope. The conditioned air in the winter, heated air, in the summer, cooled air, stays inside the building envelope regardless of the outside conditions. And we're able to remove any outside contaminants that are in the air prior to entering into the building. So this helps reduce the energy use associated both for heating and cooling of every space, and it makes the building a lot more resilient in extreme weather events and wildfire smoke, as well as just seasonal changes, as we have like high pollen season this time of year. For anyone who has allergies, I'm sure you can relate to that. When there's, you know, lots of grass or tree pollen in the air, we're going to be able to remove all of those fine pollens before it goes out into every unit.
Chris, can I ask a question?
Yeah.
Does the fresh air come into one particular unit without being mixed and exchanged with the other units?
It all gets consolidated. Well, so both actually. The exhaust air gets consolidated into big trunks before it gets distributed up to the roof. The supply air, the fresh air that's coming back down, gets distributed individually to each unit in an isolated way.
Okay.
So it's a combination of both. Yeah.
Okay, great, thanks.
The next system I want to talk about here is the hot water heating. So I suspect you're all familiar with a conventional tank type hot water heater. When they're electric, typically there will be a big heating element in the top and bottom of the tank. The tank gets filled up with cold water, those electric elements turn on, and they heat the water up. This system that we're using here functions basically like an air conditioner in reverse. So when an air conditioner is taking refrigerant, compressing it, releasing that refrigerant under pressure to then extract heat out of a building, this is going the opposite direction, where we're pressurizing refrigerant to really extreme pressures to make it extremely hot, and then transferring that refrigerant into water. The heat from the refrigerant goes into the water, and we have hot water. So we'll have 4 large condenser units like you pictured here, which look basically like an air conditioner unit on steroids, which will be located on the roof of the building. And these will be the outdoor component, which will be collecting temperature from the ambient temperature of the outdoor air, and then transferring that temperature into the refrigerant, compressing it under really high pressure to heat it up, and then transferring the temperature from the refrigerant into the water to create hot water. So this is not a new system. It's been pretty well established in a smaller scale. It's a little unusual to apply it in a building of this size. So that is one thing it's relatively exciting about this property, is that we're not, I won't say we're pioneering this technology, but it's certainly something that is unusual to see in multifamily housing like this. And this, one of the things about this type of system that has often been criticized is that under very low temperatures, historically, the heat pump systems like this have not performed very well. This system, with the way in which it's designed, and the fact that it's using pressurized CO2 as a refrigerant rather than a synthetic refrigerant, will operate and produce hot water at the temperatures we need, all the way down to -13 degrees Fahrenheit, which is pretty much like the most extreme weather possible for this part of the country. And it operates at 100% efficiency down to about 25 degrees Fahrenheit. So we're basically hitting 95% of days, we're able to operate the system at 100% efficiency. And then those really extreme cold days, we're still able to produce enough hot water. So that's a real benefit here as the technology has improved.
How noisy are they, Chris?
They're not noisy at all. They're actually very quiet. So if you've ever seen a modern day outdoor heat pump condenser unit, those sort of skinny rectangular units with the fan in the front, those fans operate at fairly low speed. And the same is true here for these. The fans are typically on, but not it's not a noisy fan in the way that you would see those big old air conditioner units making lots of noise. So we've come quite a long way from that era of air conditioner and outdoor condensers.
Okay.
That's all I have. I'm happy to take questions about sort of either the 2 big systems that I talked about and what's different about the project, which is really those 2 big components, the balanced ventilation and the heat pump hot water systems. So those are the two biggest things that are different. But if you have other questions about other elements of the building, I'm happy to answer them.
Yeah, Chris, when you and I first connected, I was asking you about EV chargers. And I think you said you are planning to have that.
Yeah, we will have electric vehicle parking as well. Yep, that's right.
Okay. And over at Mary's Woods right now, those are all free. I don't know how where you guys stand on that, but
we haven't picked a manufacturer yet for what the equipment will be, and we don't know actually what the options are yet for what the range of possibilities is. That's something that we're going to work on as we get a little deeper.
Yeah, part of my pitch would be it's the software that really makes the difference, and you can put different software packages with different hardware packages. I would lobby you to pick a software vendor that doesn't require you to sign up and establish an account and put money on deposit. A bunch of them do. Over at Mary's Woods, I think it's SemiConnect. They may use OpConnect also, I think. It's
well, I may be in touch with you, Duke, when we get a little farther down the road in terms of figuring out some of these logistics on the implementation.
Okay, great.
That's something that we haven't to do yet, is to provide electric vehicle charging. That's relatively new in terms of a code requirement. So that's something that I'm eager to learn more about. So yeah, I'll definitely get back. I'll give you a call and pick your brain a little bit on what the optimal is on that.
Great, thank you.
Yeah.
So my question would be, what do your structural engineers say about what needs to be done to make this building stable in a large earthquake? Because you're sitting on alluvial soil there that's not very stable.
Yeah, the soil conditions are fair. They're not poor. So in terms of structural
integrity.
Yeah, the integrity of the soil is not terrible. It's a class B soil, which is sort of like, yeah, fair but not unstable. And because of the type of building, this is all wood construction on a concrete slab with spread footings. And because of the shape, a U-shaped building like this is also a strong form because you have those two big corners to hold everything together. So structurally, there's nothing about this that is really out of the ordinary. We are building it to the most current seismic code, which were adopted about a year ago, a little more, 18 months ago. And that assumes more ground shaking than the previous set of codes did. So it is more robust in terms of structure than it would have been if we were designing this, you know, two or 3 years ago. But in terms of the materials and the mechanics of it all, it's fairly conventional in terms of the structure.
Do you know what magnitude earthquake this is designed for?
Oh, not off the top of my head. I can look it up.
Okay, thanks.
Yeah.
So Chris, I got a few questions here.
Sure.
So was there thought given to solar and or solar plus battery storage?
We have solar designed into the building already.
Okay.
We'll have to do a little bit of massaging in terms of understanding exactly what quantity of solar PV panels we can get on the roof, because some of that is being dictated by the access clearances of all of the other rooftop equipment that we have. Like I mentioned, the air handling and water heating equipment, as well as we have some additional insulation on the roof structure, which is creating some challenges for the solar engineers to figure out how to fasten the panels through. But yeah, we're designing the building for solar. We haven't been able to pin down exactly the quantity of panels and kilowatt hours we'll be able to generate though.
Okay. And then you talked a little bit, it's all electric, and you talked about the ventilation, is it heat pump space conditioning?
Yep, that's right.
Okay. And then, so it'll have cooling with it also.
Yes.
Okay, great. I had another question, but I don't want to hog the time. Anybody want to get in there before I ask another question?
I would ask a question about keeping smoke out.
Yep.
How does that work? Can you seal it off? Like somebody could close all their windows? Can you seal that ventilation system off?
Yeah, exactly. So in a smoke event like we are now seeing pretty regularly, with the windows fully closed and the way that the building envelope, the sort of air barrier of the building is designed, it will be not fully impervious to leakage, but it will be very, very tight. And so the filtered air that will be delivered to each unit through that centralized system will be coming from that rooftop mounted MERV 13 filter. So you'll be able to have fresh air that's not encumbered by any of the exterior air conditions that may be at like hazardous levels, for example.
I thought you needed more like a MERV 16 to filter out the smoke smell. 13
is the minimum for the hazardous elements of smoke. I don't know about whether the odor is also a part of that, but I know 13 is the minimum that we were given from our mechanical engineers.
Any chance that you can go above the minimum?
Possible. I'll have to ask. It depends on what the drag coefficients are, because the thicker the filter is, the more drag there is on the system. So it's possible. I can certainly reach out.
Okay.
Chris, going back to the solar, you've got a lot of land around there too, so that you could put solar, in some of the lawns there. And I guess with that in mind, are you thinking about getting enough electricity out of your solar to have the building to be self-sufficient, where you don't, if the grid goes down, you could support your services?
We'll be able to support most of the main functions of the building with the size system that we know that we can fit on the roof. All of the essentials, not every last piece of the building, but we'll be able to be pretty self-sufficient just with what we've designed in now. I will say we don't control any of the land outside of the property that we're building. So the fate of that land is in the hands of the Sisters of the Holy Names, and we don't have any say on most of the land outside of the confines of our lease area. And to your question of battery storage, it's not something that we've gotten into yet. It's something I'd like to see us design in the future to most of our properties, so that we can have some amount of resilience in an event like you talked about, where we can operate self-sufficiently, especially in a nighttime event. So yeah, that's something that I'm eager to look into with our electrical engineers to figure out both the possibility of adding it from a technical position as well as the cost associated with it.
Yeah, you may be aware, I think it was last year, we had an ice storm and electricity was off in a lot of places for multiple days, 7, 8, 9, 10, 11 days. So I'm assuming that you would not put a diesel backup system there.
No.
Yeah.
No.
Okay.
We will be undergrounding all of the power lines. So we're going to be going all the way out to the about 1,000 feet towards Pacific Highway to a vault that PGE installed a few years ago. So we will be on a more reliable source of power than a lot of the other buildings on campus. So that, fingers crossed, will help reduce the possibility of a really protracted period of blackout.
Duke, have you told him about if money's an issue? Well, money's always an issue. About the community solar options we're looking for at LORAC?
No, I did not.
Okay, so maybe just get your email, send you some information about, we're looking at another site and hope it's the model for the future to have Lake Oswego individuals invest in solar in different places. They get a very small rate of return, but they feel like, you know, they couldn't put solar on their house, so they're going to put solar on some other place. It's used by a lot of the churches in the state, the special way of doing it. So if there was, if money was the limitation on solar, there might be this other option. I could just send you this information. Are you aware of this?
I'm happy
Oregon?
happy to read through it. Yeah, no,
Okay.
I know of programs like that. I'm not familiar with the one specifically that you're referring to, but I'd be happy to read about it.
Okay. So another question I had is, it's a slightly delicate question because, you know, affordable housing has gotten a fair amount of pushback in Lake Oswego. And what are the discussions on our board? We've, you know, really tried to support affordable housing, but is around the parking issues that among our board, there's a disagreement about the value of parking and wanting to limit, on one side, limit parking as much as possible as to help people find alternatives. And the other side is, my side is like, what do people who in affordable housing want? Is parking a goal for them? I mean, they're in affordable housing and maybe now for the first time they can get, you know, a car.
Yeah, that's a good question. It's something that we always wrestle with a little bit. The reality is, and what we do, I should say, is largely what would be often referred to as workforce housing. So the vast majority of the families that we serve in our properties are working families with incomes that are just too low to be able to support a decent place to live within close proximity to amenities and services. But most of them have vehicles. Now, the context is different every time. This is a circumstance where the parking is in no short supply already on campus, and we're actually reusing an existing parking lot and adding a handful more spaces because we had to repave some areas anyway. But in general, yes, our residents have cars. And the question is really about what is the surrounding context, and is this a place where curbside parking is common and acceptable, like it might be in a Seattle or Portland, Tacoma, Bellingham, or not? And if not, then we have to think through what the right amount is. So it really is hard to say with any certainty, like what is the right amount of parking per, you know, how many parking spaces per unit, for example. That's a really difficult question to answer. But yeah, we wrestle with it. I can tell you parking is very costly to build. If you have to build anything that is either if it's a parking in a structure above ground, the construction cost is at minimum 10 to 12,000 per space. If it's below ground, it can be upwards of 40,000 per space. And it usually goes up by $3,000 to $4,000 per space per level below grade. So if we're doing 2 levels below grade, we could be spending $40,000 to $45,000 per space. And we just can't afford to do that, frankly, with the funding that's available to us. So sometimes the funding constraints are part of that calculation.
There is a lot of parking spaces though on that campus. You know?
Yes, this one was unique because we could reuse an existing parking lot that was already there. All we have to do is surface it, restripe it, and we're basically done. So in that sense, this one was a straighter line than some of our other projects.
I had a question in regard to the landscaping. Like what area is under your control?
Basically everything within 15 feet of the building plus that courtyard. So it's not a lot of the open space that's changing in any substantial way.
Because I know you talked about, I'm always an advocate of the backyard habitat program and planting natives. And
Yeah.
one of the things we're big on is transitioning to electric equipment away from any gas powered landscaping equipment. So I'm not familiar with the landscaping practices, but that would be great to have like a green zone and have no gas equipment used in this area.
Yeah, that's a discussion we've had with the Sisters of the Holy Names as well, because we're going to try to find some operational efficiencies and share a landscaping contract. And I know that's something that that's a real strong priority for them as well. So yeah, I think that's a great point, and we'll continue to push for that and work with them to achieve that.
Well, we have some good landscapers that are doing, some great work in regard to using electric only and hand tools. So if there's some discussions in regard to looking at landscaping possibilities, happy to help.
Absolutely. Yeah, that'll be a little ways down the road.
Yes.
But
And I'm envisioning wouldn't that be great to have a big community garden right on that grassy area?
yeah, no,
Food. Yeah.
Absolutely. Yep. I agree. There's lots of potential there.
So who would have a community garden would probably be more than 15 feet away from the building, one would think. Who would have the say over that, or a playground for the children that would live here?
So we'll have in the courtyard, we've reserved space for raised beds. And a playground in there that was within our sort of realm of control over the property. And then as it extends beyond that, that's when we kind of merge with the rest of campus, and that is still under the full control of the Sisters of the Holy Names. So they would be the ones, and certainly they're willing to consider things that we would bring, or that other tenants of the campus would bring up. But yeah, it is a little bit of a balancing act there for sure.
Okay, anybody else?
Chris, is there anything that you can think of, way that we can help you? This is just a fantastic.
Right.
This sounds wonderful.
Yeah, well, I appreciate that, and it's nice to just get in front of more people, and I appreciate your support for the project. I think one thing that I would just hold up and say is that the things that we're doing on this property for sustainability purposes are more expensive than the conventional way of doing things, but it's not that much more, and it's not that much more complicated. So I would just be on record as saying, for future projects, as you hear of things coming up, or other people pursuing, sort of larger scale multifamily or mixed use developments that are looking for sustainability measures, with a little bit of pushing, it is possible to do it, and it's not that hard. So I would say, as you're having these discussions with others, don't be shy about sort of nudging them along, because it really isn't that much more work.
Would there be operational savings that would help offset that?
Yes and no. The equipment draws a lot of power when it's all running at once, but if it's a daylight hours and we're on a warm day, we're going to be generating as much electricity as we need, probably. So it's hard to say at this point. Right now, we think it's probably going to be about the same cost as if we had more conventional equipment. That's what our engineers have told us on the sustainability side. So it really depends on the magnitude and the amount of on-site production you have.
And will each unit be paying their own electric bill, or is that all? Okay.
They will, yeah. And then we'll be paying for all the central equipment, water heating, and the ventilation systems and all that, and the corridors, common areas, that sort of thing.
Would they be able to see any difference in their bills if they
Yes.
are more conservative with their use?
Yeah, absolutely. Yeah.
Okay.
for sure. That's a real benefit.
Chris, what's the time scale of all this?
We're looking at breaking ground in August, and it'll be about 16 to 18 months of construction. So early 2024 is when we would wrap up and start move-ins. January, February 24.
Cool.
And how do you get tenants, or how do you screen them?
Oh, that's a long and complicated question.
Okay.
That's a can of worms. It's all based on income qualifications, and it's a really I'd need like another 45 minutes I
Sure.
think to answer that one.
But that's something you guys take responsibility for?
That's right. We manage our own properties and provide resident services on site.
Okay. Okay.
Yeah.
Okay.
And we'll have
there any-
on-site staff.
Is there any thought to giving priority to people who work at Mary's Woods?
For fair housing purposes, we're not allowed to make a special preference for any particular employer. However, we can make them aware of the opportunity to live there. So
Okay.
they certainly will be eager to learn more, I'm sure.
Mhm.
Well, Chris, thank you so much. I echo Linda's point. This is really great. It's better than I anticipated. So thank
And
you.
the-
Well, thank you all for your time today. I appreciate it. I've got to jump onto another call. I apologize for leaving abruptly, but it's been great to spend time with you all, and I look forward to being in touch with you again.
Good.
Right.
Thanks.
Thank you.
Thanks, everyone.
Yeah.
Okay.
Bye.